There you go. So, left off last class, thinking about the different costs, or our cost structure for our firms, kind of where optimal quantity decision is going to be. So the main kind of final takeaway that hopefully we had last class was that if I'm thinking about, here I'm going to kind of connect the two real quick. So let's say over here, I've got different quantities that the firm can choose. I know that their marginal cost curve is going to kind of look like this Nike sign, right? Where it decreased initially because of specialization, but over time, right, we're getting less and less productive workers, and so our costs are increasing. Right? We also have our average total cost curve, and our marginal cost should intersect that at its minimum point. We also said they're going to take the price as given, right? Whatever the price of the good they're selling is, they can't really deviate from that because it's this perfectly competitive market. So where does that price come from? I've already drawn this a little bit out of scale, but for the sake of this example, we'll kind of go over it. So if we look at the market supply and demand, so here is our quantity decision for a firm. We have many firms in a perfectly competitive market, and so the market would reflect all firms. So the market is what decides the price, right? We talked about supply and demand. The equilibrium price is going to be wherever this market supply is equal to the market demand. So really what we're saying there is for each individual firm, they have to take this price as given. That's what they sell their product for. So their marginal revenue curve is essentially the same as whatever that equilibrium price is. The additional revenue they can earn from selling each good is just whatever the price of that good is. So the market is kind of connected to the firm's decision. Right? The market price will affect the firm's decisions because we said last class, the point where profits are maximized is where that price is equal to marginal cost. But if we think about it this way, when people make decisions, you purchase something as long as the marginal benefit is greater than the marginal cost. The firms are doing the same thing. If the marginal benefit to them is additional revenue, is greater than the marginal cost, the additional cost, then for all these units, right, they're gaining more revenue than it's increasing their costs. Right? So for every unit here that I sell, I'm going to receive more money from selling it than what it costs me to produce it. Right? Or think about it this way. The change in profit is really just going to be the difference between the change in the benefits or the change in revenue minus my change in costs. Kind of think about that difference between marginal revenue and marginal cost as being marginal profit, right? The additional profit kind of added by selling that unit. So for all these units, marginal revenue is greater than marginal cost. They're equal at this point. So where they're equal, we say we're indifferent, right? We either produce that and provide it to the market or not. It won't affect our profits, right? Because the difference is zero. So if I produce it and sell it, I added zero to my profits, so my profit will remain. So we say we're indifferent at that point. So this is the highest quantity level that we can produce up to. So we said that was kind of our equilibrium quantity for the firm, because that's where we would maximize economic profits. Think about it this way. If the difference between marginal revenue and marginal cost here, it's all positive, right? So our change in profit will be positive where profits are increasing. Right? So for all these quantities, as we produce them, we're increasing profits up to this point. If we go past that point, well, now the additional costs from producing that good are greater than the additional benefits or the additional revenue. So for every quantity here, this difference would be negative. So the change in our profits would actually be going like down. It's a negative value. So our profits would be going down. So that's why we would stop at this point. Right? That was the last unit where I either added a positive amount to my profits or I added zero. Right? So this is the idea behind what we're doing. If we're looking at a graph like this, we said what's the equilibrium quantity? if the price is 450, so we go up here to 450. Actually, I might use the mouse here. So 450, we go over, that would hit my marginal cost curve, which was this blue line, right? The kind of check mark line here. So we go over, the point that I'm at in that blue line at a price of 450 would be a quantity of 350, right? Halfway in between 3 and 400. So that's kind of where we left off. So there's also another way to think about profits. Right? Profits we could just write as total revenue minus total costs. And kind of give an idea behind why profits are maximized for those of you that like math. So I've got my profits are total revenue minus total cost. If I want to think about, well, where is the change in profit, right, going to be at 0? So I'm thinking about the change in profit, the derivative, in respect to quantity. Well, if I take a derivative of total revenue, what that's really giving me is kind of the change in total revenue from a change in quantity plus a change in total costs or a change in quantity. This is just marginal revenue. Actually, not plus, sorry, minus. So this is just marginal revenue minus marginal costs. So the change in profits will just be the difference between my marginal revenue and marginal cost. That's where that comes from. I think it's a little bit of mathematics. I won't ever make you do that. But that's where it's coming from. So I could just focus on my totals, right? And then choose where do I see profit greatest. So we had all these, we have total revenue greater than total cost. My profits are positive. If my total revenue is equal to total costs, we say profits would be 0. And then if I have total revenue being less than my total costs, my profits would be negative. It's not too wild, I don't think. Or I'm incurring a loss. So if I looked at a cost structure like this, and I have these different bushels, different quantities of this good, I've got the variable and the total cost associated with each one of them, and then I calculated the average variable and the average total. So to produce that average variable and average total column, what did I have to do to my total and variable costs? At each quantity, I simply did what? So how would I get an average? So that's the average of two numbers, right? So if I think about something like, let's say I've got 1,000 units and it cost me $1,000 to produce those 1,000 units. On average, how much did each unit cost me? Someone holding up their finger, right? $1. Because I had this total cost of $100, and I would just divide that by the 1,000 units I was producing. I think when the number's the same, it's kind of easier to think about. If I had $2,000, right, it cost me $2,000 to produce these units, and I'm still producing 1,000, what would my average total cost be there? Now it's just 2,000 over 1,000 or 2. So I'm just looking at my total and dividing it by the quantity. Now here, I'm going to have different total costs at every single quantity. So for the first one, right, 30 divided by 1, average total cost is 30. 36 divided by 2, right, average total cost would be 18. 44 divided by 3, so on and so forth. That's how I'm coming up with that average total cost. Same idea when I want average variable cost. I'm just going to take my variable cost and divide it by however much I'm producing, the quantity. So 16 divided by 1 is 16. 22 divided by 2 is 11. 30 divided by 3 is 10, so on and so forth. Now, if we look here, right, we could actually come up with, we would have to come up with total revenues now in order to choose what quantity the profit is highest at. So I would need to know the price of a bushel of tomatoes. So let's assume that that price is 14. Now, it's been two ways to kind of think about where would profits be maximum. Oops. So what I could do is go through and take every single quantity and just multiply it by the price. Price times quantity, that just gives me total revenue, right? It's how many I'm selling times how much I'm selling them for. So I could create a whole other column, which I would take, 1 times 14, write that number down, that's my total revenue at a quantity of 1. When I sell 2, it would be 2 times the price, so 2 times 14, that would be my total revenue. I would then have this column of total revenue, and I could just take the difference between total revenue and total cost to get at my profits. What I also know is going to be true is that the quantity where my profits will be maximized, even if I don't want to go ahead, create this new column, find the difference in total revenue and total cost, it should be where that price is equal to my marginal cost. So if I go back, what quantity would my price be equal to? Actually, we don't have marginal cost up here, so we'll scratch that example. Well, we could still do it, right? Let's see what we got. So you can kind of see here, if I use my total cost curve, how can I come up with my marginal costs? The marginal costs, except for what? Yeah, marginal just means what's the change, whenever I'm looking at marginal, my marginal cost, marginal revenue. So what's the change in cost or what's the change in revenue from a 1 unit increase, right? Or a change in quantity. Usually here we have 1 unit. So if I'm thinking about marginal cost, it's just my change in total cost from the change in quantity. Well, here we have an easy example where the change in quantity is always 1. So all I'm doing really is looking at how much does total cost change. So if we think about these different quantities, we could actually come up with the marginal cost. So what's the marginal cost of that first unit? We don't have the 0 one to compare to, so can't really find a marginal cost there. What about the second unit? Going from 1 to 2 units, my total cost went up by what? What about going from the second to the third? Total cost went up by. What about third to the fourth? And it doesn't really matter for the fifth, I'll show you why. Or actually, no, it might. What's the fifth? 16. Okay. So I believe I said, what if the equilibrium price was $14? Well, if I think about producing this first unit, I should have a comparison group of 0, but we don't here, so it's okay. What we'll assume is that we know the marginal cost would at least become lower than 60. So for that first unit, let's assume that I was able to calculate my marginal cost for this unit being 4. Would I produce and sell that first unit? Why? Yeah, remember, the equilibrium price essentially tells me my additional revenue. So I'm making $14 by selling that first unit, and it only cost me 4 to make it. So I'm making positive profit. What about selling the second unit? Well, the benefit is still greater than the cost, right? Or the marginal revenue is still greater than margin, so yes. What about the third? Yes. Fourth? Yes. Fifth? And now my costs are slightly higher than the marginal revenue. So I would kind of stop at that 4th unit. So we could use marginal costs and marginal revenues to determine kind of where that equilibrium quantity is. Kind of notice, like draw this out graphically. Now here we're making 1 unit jumps, so it's not truly a continuous line, but it was kind of some nice easy number example for us to see it with actual numerical values. But if we had more continuous production decisions, maybe instead of bushels, we're actually measuring like tons, and so I can do fractions of tons and things like that. You can kind of see it's going to be wherever that price hits my marginal cost rate. And here, I happen to hit it between that 4th and 5th unit, and so I'll produce that 4th unit, but not the 5th. Any questions on this before we keep moving here? Okay with that? So we had another equation for profit, which was slightly just rearranging this one. So we said we could also write profit as kind of whatever that equilibrium quantity the firm decides to sell times the difference between the price and average total cost at that quantity. So in this scenario, right, what would my profits be? In the slides. So my optimal quantity here, we said the price is equal to marginal revenue. So that was what a quantity of 4. At that quantity, what's true about the relationship between my price and my average total cost? They're the same value, right? When I say price, I could also say it's also the same as the difference between my marginal revenue and average total cost. My marginal revenue is just whatever that price in the market is. So if I had a situation like this, I'd actually be at a profit level of 0, right? Because no matter what quantity I produce, if the price and the average total cost are the same, anything times 0 is 0. What about if I had a scenario like up here? So I identify my equilibrium quantity, wherever that price, equilibrium price, my marginal revenue, hits my marginal cost. So identify that quantity. At that quantity, my price is here. Got a dead marker. So my price at that quantity is there. There we go. And my average total cost is somewhere up here. So I'm kind of think about it as this area is going to represent my profits. The only problem is my average total cost at the optimal quantity is now above the price or the marginal revenue at that optimal quantity. So here, even though I'm maximizing profits, my profits are actually negative because the average total cost is greater than that price. So even if we maximize profits, sometimes the maximum level of profits we can get to are negative. Now we'll talk about in a second, what do we do if that's the case? But for now, just know that if we end up at an optimal quantity where the average total cost is above my price, my profits will be negative. Let's say, and kind of erase this. So let's go back and say, I don't know. We had our old supply. I'll try to get it to line up actually. So here's my equilibrium price. So before I must have had it drawn something like this. Right? And we were saying equilibrium price kind of led to negative profits. I'm going to kind of jump a little bit ahead here, but I think it's valuable kind of where we're at. So let me get a different color. If I have negative profits, right, what do you think some firms in this market might start to do over time? If I'm making negative profits, right, I'm actually better off if I just stop producing, right? At least then I'll have profits of 0, right? So actually not producing would be maximizing profits here, because if I decide to choose the optimal quantity given my cost structure, I'd actually still have negative profits. So I might as well just leave this market. As firms start leaving the market, we see a reduction in the number of producers or sellers. So what's going to happen to my market supply and demand? If I have fewer producers, I'm going to see a supply shift, and it's going to be a supply decrease. So I have fewer producers. So that decrease was kind of like a leftward shift, or kind of a movement towards 0. So now if we think about, maybe my new supply curve is up here. My new equilibrium price is now higher. At this new equilibrium price, the firms now face this higher marginal revenue curve, the optimal quantity, and it kind of makes sense. If the price of this good in the market goes up, for one individual firm, they're making more money selling that good. You can envision they probably want to sell more of it. Sure enough, the point where that marginal revenue hits marginal cost, call this star, I guess, is going to be at a higher quantity. And at that higher quantity, notice my average total cost, the difference between that and my price represents profits, but now, because that price is above average total costs, that area represents positive profits. So anytime I kind of have this marginal revenue curve hitting marginal costs below my average total cost line, I'm going to have negative profits. Anytime that marginal revenue or the price hits my marginal cost curve above the average total cost, now I know that that kind of rectangle will represent positive. And really the reason why comes from this equation, right? The sign of my profits is really whatever the sign of the difference between the price and average total cost are. But yeah, the changes in the market, right, directly impact the firms that stay, right? I said some firms will leave, but the ones that remain will kind of switch from having those negative profits to, if the price goes high enough, eventually get positive profits. So we said in the slides here, this was a representation where profits were zero. Right? So we can kind of think about the point where profits would be equal to zero actually happens to be at that lowest point on the average total cost curve. Right? Because that's the only two places where marginal costs and average total costs are exactly the same, right? Is right here. So this would be kind of what we call our break-even point, right? If the price goes higher than that, so if the price goes higher than that minimum point on our average total cost curve, well, now we know we have positive profits. If the price goes below that minimum point on my average total cost curve, well, now I know I start to have negative profits. Is that any questions on that? Is that clear? Is that rephrased? Or? Okay, so we've talked about kind of this is the point we'll call our break-even point. We talked about the optimal quantity decision rule. We then talked a little bit about prices. So I think here I just gave you an example in the slides, very similar to what I had up here on the board, which is showing you, okay, what if the price goes from $14 to $18? Well, now it hits my marginal costs at a higher quantity. So now the optimal quantity is 5. And at this point, my new price, this quantity is above the average total cost. So I'm going to have the price is above average total cost, so positive profits. If I then, excuse me, you could go through and make the calculation, right? I think here I gave you the average total cost was 14.4. So you could actually find the difference, right? Take that price of 18, take that average total cost of 14.4, plug them into our profit equation. Then take that difference and multiply it by the optimal quantity the firm chooses, which here is 5. Is it clear how you would do that, right? So all you're doing there is taking you're taking that optimal quantity of 5 and then multiplying that by the difference between the price and my average total cost. I'm just plugging my values in there at that point. Okay? And that would tell me the level of profit. I could then think of what if the price went down from $14 to $10. Had a similar example on the board. Now, our price intersects this marginal cost. And here's kind of a weird one. And this is usually why when I'm drawing this out, I actually will tend to like ignore this part. Because notice here, if I had something where I had the price was low, it intersects the marginal cost for the price. Right? And that's because of this fact that initially we might have this specialization going on. Right? So we're really only ever concerned with the cost curve that's increasing. Because we know here that, well, our costs are still declining. So we don't want to make any quantity decisions if our costs are still going down. Right? So if you had a scenario like this where the price gets low and it looks like it might intersect the marginal cost curve at 2 points, you're kind of always looking at that point that's to the right, the higher quantity. Okay? So, and then that would play out if you actually calculate, you figure out if I produce this quantity versus this one, right, my profits are actually still going up because that cost is still declining, the marginal cost is still declining. So here, my price hits the marginal cost curve on the portion which is increasing, right? It intersects the portion of the marginal cost curve that's increasing at a quantity of 3. So I would plug in my quantity of 3 instead of 5 now. The price is 10. My average total cost is 14.67. Right? So if I plug in 10 and 14.67, now that difference is going to be negative, and this would actually represent maybe economic losses, right, or negative profits. And kind of notice when I had prices that were below the price that we call the break-even point, it led to an economic loss. When I had a price that was above that break-even point, break-even price of $14, well, that actually led to positive economic profits. So anytime I have a price that's above that break-even point or above that minimum point, my average total cost curve, I know I'll have positive profits. Any price below that minimum point in the average total cost curve, I know that will result in negative profits. Okay. All right, so you can go through and do the actual kind of calculations. So it should be pretty easy at that point, right? Once we identify the three values, it's just plugging into that profit equation. Any questions on that before we keep moving here? All right, so kind of already showed you how we could see things in the market change and see how those would impact firms. So, you know, if I saw a demand increase, I guess these lines are a little hard to see. I should probably change the color. I don't remember making that neon green. Right, if I see this demand increase, that pushes the price up, right, and potentially pushing me to higher optimal quantity levels, and eventually potentially switching from negative profits to positive. We already had this kind of up on the board here, but this is just kind of depicting that. You know, I did a little bit about order, but I want to make sure you realize changes in the market supply and demand will still impact the firms because it's altering that equilibrium price that they're able to sell their good for. So we've got profit equations. Let me get all this up here. Whoops. So, you know, sometimes, and I had someone come in for help yesterday, and they were kind of asking, well, when do I use this equation and when do I use this equation? And it's really about what information we have. If we have information on total revenues and total costs, well, it's pretty easy to just calculate profit by taking the difference between the two. But if I've got price, quantity, and the average total cost, right, then I'm just going to use the formula that uses those two components. So it really is just dependent on what components you're given. Right? A lot of the times when we're looking at the graphical or the visual representation, it's a lot easier to identify these three pieces of information than it is total revenues and total costs. Any questions? All right, so hopefully we kind of have this idea down a little bit about how we choose the optimal quantity and then how we can figure out what profits are. So positive profits, negative profits, or the profits could be zero. If we have negative, well, start with the easy one. If I have positive profits, am I going to decide to remain open and produce that optimal quantity, or am I going to shut down? If I have positive economic profits, why am I shutting down, right? I'd be a lot worse off. I'd be at zero then. Now, one thing I didn't draw up here yet that starts to play a role in the shutdown decision is not only do we have average total costs, in the short run, we actually have average variable costs as well. So potentially, right, in the short, if I have some of these fixed costs existing, even though I have negative profits, it could be a lower negative value than if I shut down at all. I'll kind of phrase it this way. If I have to pay, let's say my fixed costs, like, so this is like, I don't know, the factory I'm using and some other kind of machinery that's already been paid for, my fixed costs are already at $1 million. So if I decide to shut down and produce nothing, well, then I'm still paying $1 million. My losses are $1 million. Right? Still have to pay those fixed costs. However, if I decide to stay open and operate, potentially, right, I can, choose my optimal quantity and determine that from staying open, right, the amount of additional kind of revenue, or the difference between the additional revenue and additional costs that I incur by staying open, right, I was actually had positive 500,000. So by staying open, I was able to increase my profits by 500,000, but I still had to pay that $1 million in fixed costs. So now instead of being out $1 million, I'm only going to be out 500,000. So staying open, I was able to kind of minimize my losses. Right? So we're thinking about shutdown decisions. It's only when profits are negative, right? I'm not going to shut down if my profits are positive, but potentially, even if I have negative profits, I'm kind of minimizing my losses by staying open as opposed to just shutting down and incurring those fixed costs. Right? So, sometimes in the short run, actually shutting down is better off, but not necessarily. So what point is it, what's the cutoff point for where I should decide to stay open and minimize my losses, or is shutting down actually minimizing my losses? In the case where, so if I go back here, in the case where I'm thinking about the long run, and my average total cost just reflect my average variable cost, because nothing's fixed in the long run, I can change everything. In the long run, if I have negative profits, then it always makes sense to shut down, because if I shut down and nothing is a fixed cost, my new profits will just be zero. Right? But if I have some of these fixed costs, it might not be as clear cut. And at what point should I decide to shut down? At what point am I not kind of eating, minimizing those losses I'm incurring? So down here, I kind of gave kind of a setup here, right? If the losses from staying open are greater than the losses from shutting down, then I decide to not shut down in the short run. So, we can think of real world examples where we have shutdown decisions. So actually a lot of industries do this kind of, not like shut down completely for the year, but for different seasons. So, if you think about like ski resorts in the summer, they've made the decision that staying open in the summer, right, they're not minimizing losses there, right? Because yeah, they're still their fixed costs, but they're not really making any money by remaining open, right? So it's not, staying open there wouldn't minimize my loss. Some restaurants have decided that, look, in the winter, right, the cost to kind of keeping the business open, right, aren't great enough, or aren't compensated by a huge increase in additional revenues if I'm like in a resort town where people only come there in the summer. So I'd imagine a lot of places like in Florida. I grew up kind of like Southwest Michigan. There's a couple restaurants there that are like slammed in the summer because there's a lot of second homeowners from Chicago. But all of them are closed in the winter because the local towns are like size of like 2,000 people, right? There's kind of along the lake there. So we can think about seasonally, we might have this shutdown decision as well. This is not just a shutdown decision of like leave the market completely. It could be we make this shutdown decision for different seasons of the year as well. So my shutdown rule is going to be that as long as I have positive profits, I stay open. But if price is below average total cost, I know I'll have negative profits. And if I kind of rework my profit equation, in the short run, I can break down my total costs into fixed and average. So really what it comes down to is if I choose a quantity of 0, so you can work through this. I mean, all I did here was I know my average total cost is average variable plus average fixed. So I just broke that down into its two components. I then just rearrange things a little bit. If I take my average fixed cost and multiply it by quantity, that just gives me my fixed costs. And then I kind of have this portion over here. So if I'm looking at this equation, if I produce 0, right, then my profits would simply be negative whatever the value of my fixed costs are. So if I shut down, my profits are just the negative fixed costs. If I decide to stay open, right, the only way I'm actually making my profits get closer to 0, right, because I'm at a negative value, right, when quantity is 0. The only way I can kind of decrease my losses is if this difference is positive, because then it would add a positive value to my profit equation. And now my new profits would be something that's slightly above whatever that negative fixed cost is. Now, if price ever goes below average variable costs, then this difference is negative, and I'm just adding a negative value to that profit equation. I'd actually be worse off by staying open if price was below my average variable costs. So if price is below average variable costs, then I should shut down. I'd be better off just shutting down. But if price is above my average variable costs, then I'm kind of minimizing my losses there, right? I'm not going to end up with positive profits, but I'm going to be a lot closer to 0, right? Which is a good thing, right? I'd rather only lose $1,000 as opposed to $500,000. So our main shutdown decision becomes, as long as price is above average variable costs, we will continue to remain open in the short run because we're minimizing our losses. As soon as price falls below average variable costs, well, that's when we're going to shut down. So if the price stays above average variable, we remain open in the short run and minimize our losses. So what is this going to look like visually? Where are we at on time? Okay. So I think I have a good visual here. So I've got my marginal cost curve, my average total, and now I'm adding in this average variable cost. Okay? So I'm in the short run and I'm trying to make my shutdown decision. Okay? Well, I can tell it this average total cost of $2.50, that's the minimum point on my average total cost curve. So if the equilibrium price is anything below that, I know I have negative profits. If equilibrium price is anything above that, I know I've got positive economic profits. So let's say, and then look at my average variable cost. If I look at that minimum point on my average variable cost, what that's telling me is, this is kind of like the break-even point for my shutdown decision. If the price is anywhere above that average variable cost, remember, if price is above average variable cost, then I'll actually be minimizing my losses and I should stay open in the short run. So any price above average variable, but below the average total, this would be my range where I've got negative profits, but I'm better off if I stay open. If the price falls anywhere below the minimum point in the average variable cost, so anywhere below $2 here, well, now price minus average variable cost would be negative, and I'd actually be incurring greater losses by staying open than just shutting down. Okay? So we kind of break this down into 3 regions. Here's all the price ranges for which I should shut down. Here's prices where I should stay open in the short run, but I'll have negative economic profits. Here's the range of prices where I see positive economic profits. Okay? So you can break this kind of down into 3 different ranges. And really the way that we're doing that is we're looking for, where does that marginal cost curve intersect my average total and average variable costs? Those will give me kind of my break-even points. Here's my break-even points for having positive profits. Here's my break-even point for whether or not I should stay open or shut down. Any questions on that? So if I had a price of $4, what will be true about profits here? If you don't have any questions, this should be an easy one. If the price is $4, what's true about profits? Yeah, well, that's above that minimum point in the average total cost, so it'd be positive. Okay? What if my price was $2.20? What should I do? Yeah, I'm operating at a loss. You can kind of think about it as anything here that's not green, it's all at negative economic profits. But within this band, this yellow band, these are all prices for which I would still remain open because I'd be minimizing my losses. All right, so we got this kind of just a nice little summary of those ranges. We'll actually work through, we got 12 minutes. So I think I've got, let me see what else I have left. I might hop around a little bit here. So I basically just have, okay, we'll work through some of these. So, you know, I don't want to go too much into this, but one thing that we might think about is these are only decisions made in the short run. In the long run, right, it's going to be that all my fixed costs become variable costs. So my average total and average variable costs will become the same thing. So in the long run, we're going to be looking at a cost structure like this where there's no variable costs. So in the long run, there really is no kind of stay open and minimize loss decision. In the long run, if I'm earning economic, negative economic profits, I'm actually better off to just shut down and do zero. Right? So that kind of hinges on the fact that we don't have any costs that we have to pay regardless of our production decision. There's no fixed cost in the long run. But with the short run, there is. So we have these different kind of ranges, right? Where we might shut down, stay open, or stay open but have negative profits. So let's work through some of these, and hopefully you can kind of see these okay. I more so just want to kind of get an idea about where we're at. I don't think any of the values are too close, and I'll try to help you out if kind of just, it's hard to see a little bit. So here, if I'm thinking about a break-even price, that's going to be the point where profits are equal to zero. So just kind of a reminder, even though they're not labeled, this blue curve represents my marginal costs. right? And I know it represents my marginal cost, or at least I've tried to draw it to the best of my ability, because it intersects my average total and average variable cost at their minimum. So if I'm looking at that black and green line, those represent my average total and my average variable costs. Which one do I know has to represent my average total costs? The black line, right? Average total is my average variable plus my fixed costs, average fixed costs. And then this red line would kind of represent our average fixed costs. Okay? So that blue line is marginal cost, that black line is average total, and the green line is average variable. So if I'm looking for the break-even price where profits are equal to 0, what would that price be? So like I said, if you should be able to see, I think, from back there, right? All these ticks, right? If this is 2 and 300, the middle tick here would be 250, and then kind of these gray lines would represent 25s. Right? So if I'm looking for what price would that would be where profits are equal to 0. So I'll give you a little bit of time to look at this. This is why I mentioned last class, it might be good to have this, be able to either print this out or pull it up on kind of a computer in front of you so that it's not, if you have visual, if it's hard to see this, it won't be much of an issue. So we got 26 of us here today. All right, I'm gonna close it out. So what should that answer be? So if I go to, where's my break-even point? It's gonna be the minimum point on my average total cost curve where that marginal cost intersects the average total cost. If I follow that down, actually a price of, maybe I'm not looking at this right. Maybe that's something to do. So you answered 275 or 300 there, I'll give it to you correct. This is a little bit hard to see. But this shouldn't be 275, it looks like. Right? Because here's the point. We should just go down to 300. Oh, well, yeah, that would help, right? Sorry, the quantity in which we have 0 profits is 300. 275 is the price at which, yes. Thank you. So I could ask you either one, right? But here I asked you for the price. So if I ask you for what quantity will profits would be 0, well, we can determine the optimal quantity here, right? Where that minimum point in my average total cost curve, with the price at which that would be, we'll kind of go over here to 275. Yeah, sorry about that. I've got a couple different questions here. I forgot which one we did. Any questions on this? Right, so it's just going to be that minimum point in the average total cost. Where would my shutdown price be? All right. So once again, I'll try and get this one wrong. So we're looking for the shutdown price. Why is my marginal cost curve disappeared? Is it here on all the other ones? Yeah. Okay. We'll just go through these. I want to make sure I got kind of registered here for one. So we'll talk about the rest of these. So if I'm looking for kind of my shutdown price, right? That's going to be that minimum point on my average variable cost, right? So kind of look here to figure out that what quantity that would be. Then I go over to figure out, set a price of 175. Right? So the minimum point in the average total cost tells me what profits would equal to 0. And then kind of my cutoff for the shutdown decision is that minimum point on the average variable cost curve. So I think we already did this one, right? What quantity would be where firms earn 0 profits? We already determined that was 300 earlier. And then what would profits be if my price was $450? So I won't kind of ask you to answer this. We'll kind of walk through it together. So I just want to make sure those of you showed up, we got at least one question. So you got I for the points for the day. Shouldn't be too bad. So if I'm wanting to find profits, what are the 3 components I need? Price, average total cost, and my optimal quantity. If the price was $450, what would my optimal quantity be? So I would look at 450. That hits my marginal cost curve at a quantity of 350, right? So my optimal quantity there is 350. Well, all I'm going to do is plug my values into that equation. So 350 is the optimal quantity. at that quantity, right, I know that the price is whatever the price of the good is. So let's say $450. And then at that quantity, what's my average total cost? So if I go this quantity 350, I go up here, my average total cost looks like it's right at 300. So my average total cost at that quantity is 300. Now it's just a matter of doing that into a calculator. So 150 times 350. Yeah. So it's just a matter of identifying that optimal quantity. You're given the price, and then at that optimal quantity, going up to your average total cost curve to determine what the average total cost is at that quantity. So in this example, right, at that price of 450, we've got positive economic profits, and this firm should stay open. Right? What if the price was 150? What should the firm do? Yeah, if the price is 150, right, that hits my marginal cost curve down here. My price is going to be below average variable costs, right? Or it's below that threshold of $175, which told me any price below that, I'm actually better off just shutting down. Okay. What if I had a price of 250? I go over here. My optimal quantity looks like is around somewhere in between 375 and 300, 275 and 300. But my price is going to be below average total. So I know that my profits will be, price is lower than average total, my profits are going to be negative. But those negative profits are greater, or they're closer to zero than if I just shut down altogether, right? Because it's above. Price would still be above average variable costs here. So we want to get real familiar using these cost curves to determine optimal quantities, but also what the value and what the sign of profits are. And then given that, what is given the relationship of price to average variable cost, even if I have negative profits, should I decide to shut down and stay open, minimize my losses? Any questions on this? So, this is kind of the first market we'll talk about, this perfectly competitive market. You can start to imagine, we look a little bit at today, but like the level of profits and things could be impacted by shifts in the market supply and demand curve. And if you're looking at those homework questions, you might see that connection kind of referenced quite a bit. Like, something happens where demand increases. What's going to happen to profits? What's the new value of profits? Because that market shift will change the marginal revenue curve for each firm, or kind of change that equilibrium price. Anything else I want to say here? This should set us up to next week. We'll transition into not looking at a perfectly competitive market where firms have to take that price as given. But we'll start to think about a market where we only have one producer or a monopoly. So we've got the perfectly competitive market. We can determine what the optimal quantity is, calculate profits. We're then going to transition to, okay, what if it's not perfectly competitive? What if we have like the most uncompetitive market, which is there's only one seller of the good? So once we get through that monopoly stuff, that's kind of the last batch of questions on that homework. So you should be able to get pretty far through that homework. I would say about 2/3 of the way through. Given what we've covered at this point, the last third of the questions we'll cover monopolies, which we'll start to tackle next week. All right, you guys have a good weekend, and I will see you on Monday.